I'm working on a project to do regional climate simulations for the southwest of Western Australia. We run WRF to do real-time forecasting when we want to, but mainly we're using it to reproduce sort of the climate of the past, if you want, to try to do regional climate runs. And the reason we do that is for agricultural purposes, for sort of impact studies, just to understand what happened and why it happened. Because what we can actually do with these things is, if we can make this data available, it provides a high resolution forecast to people who need forecasts, like farmers, pretty much the farming community, and just there's many people who need high resolution forecasts. So we can run the model at a 10-kilometer resolution, and you can get data at the farm scale, which is very useful. The thing with the model is it needs to run in parallel, and we need a lot of computer memory and a lot of disk space to run this model. So we've been running it on EPIC as part of the early adopters program.
These come from the Murdoch computer labs. They're at their end of their life cycle. Basically, you just plug them all together in a router that allows for them to communicate to each other, and then you set up the software, and then you install the model. The way we do it in IVEC is the system administrators set up a batch job and send it out to each node, if you like. The way we did it in this case, and the way it was done in the old days, was individually installing on each node. This particular set of computers does one job really well, and that's the job that I still do on these computers. It basically runs one single model that is designed to run in serial on one of these computers at a time, and it runs for a very long time, for about 2.5 weeks. And so, if you like, it's anti-parallel, whereas on IVEC, on the supercomputers, we're able to parallelize jobs and send parts of a job out to all nodes of a computer system at once. On this computer system, we have to put the jobs in on each individual machine by machine. After 2 weeks, it produces a single year of a regional climate model output at 1 kilometre resolution, and it chews up about 20 gigs of data per machine. So then I have to unpack that, and that takes another week or so, and then I put it all together on a drive and start analysing it. Essentially, it takes exactly the same time on EPIC. Even though it's got so much more power, the model only doesn't take advantage of the parallelism that's available on EPIC, and it just runs on a single core with a limited amount of memory. So you wouldn't be using EPIC to its full capacity. You'd essentially be using up resources that could be better employed in a really parallelized job that would make better use of the computer and probably even be more energy efficient. So we're very lucky that the new generation of models that are being developed are designed from the ground up to take advantage of that parallelism.